That's good enough. Hello and welcome back to the shop. You can see I'm on the lathe again today, and it's a very clean lathe. I gave it a good clean down on Sunday when we finished manufacturing the body for the floating Reamer holder. And I thought I'd come back on the lathe and make the little cap that holds the sleeve and the swivel pieces together. Simple little design, let me just show you. So what I'm thinking of doing is this here, and that's the piece there, I believe. Okay, so that piece there will go into the end of the sleeve, not the sleeve, the body. It holds everything in place. So I've just put the piece of steel in the 4-jaw chuck. I've just clocked it up. It's running pretty true now. So we're going to face it off. We're going to center drill it. We're going to drill it, and then we're going to bore it out to the right size. And we're going to turn in the external features on it. We're going to have the spigot on the outside. We're going to part it off as well. So it's 2-inch diameter. So you can see some big diameter steel being parted off on the little MyFed lathe here. I'll show you that obviously when we get to it. But that'll probably be one of the last operations. So anyway, I'll bring you down, you can see what I'm doing. Right, you're standing where I would normally stand. You can see, that's pretty good, eh? Maybe half as that. It's just an ordinary billet of bright drawn mild steel. I think it's EN3, something like that, EN38. Alright, you've just heard me mention the steel that we're going to use for this cover, for our floating Reamer design. And I said it was EN3A, I think it's actually EN3B. EN3B, it's bright drawn mild steel. Quite a tough general purpose steel. EN, you hear that quite a lot. A lot of older people, certainly in Britain, will talk about EN8, EN9, EN3, EN1A and things of this nature, EN24. Now, what does EN stand for? Well, these were numbers, or standard numbers, that were given to steels during the Second World War. Okay, because every industry in Britain had their own standards. The railways definitely had their own standards. The coal mines would have had their own standards. The shipyards would have had their own standards. And during the war, it was necessary for production of munitions, tanks, aircraft, and all kinds of things, ships, or whatever it was, to standardize so that anybody could make the part. So any factory could make a part, and it would be the same as the part made from another factory. So they had to be standardized. And EN stood for emergency number. So when you see EN8 or EN9, it was emergency number 8, emergency number 9. And of course EN8 is a medium carbon steel, EN9 is a high carbon steel, EN16 is a higher carbon steel, but it's got alloying elements in, I believe. EN24 is another type of steel. So that's what it was for, EN, emergency number. A lot of people still refer to it as that now, rather than come up with some code that's about this long. EN8, EN9 is that long. You know, and everybody knew what it was. We all knew what it was. So there you are, a little bit of information for you. Now we're going to face this off now. Let's have a look. I'm still going to use the slow range. I like the way that we turned that body for the floating Reamer holder, using the slow range but increasing the speed of the motor, so we got more torque. It seemed to perform better. So I'm going to start using that more, using this low range but then control the speed on the motor, rather than have it on the high range and the motor running at its slowest speed. It's not good to do that. So we'll just speed it up here. sticking the drill through now, just a pilot. Half-inch drill through now. There you go, it's all the way through. I'll put a 5/8 drill in now. I think after this we'll get the boring bar in. It's not supposed to happen. I've actually got a 7/8 drill here with a 2 Morse taper, so we'll try this out. Let's just see what this is like. You must be careful with this, though. It's quite a big drill for a little machine. There we go. That saved a lot of messing about. Alright, the boring bar. Alright, I've got the little boring bar in, the same one that we used the other day on that silver steel for the main body. Did a good job there. Let's see what it's like with this ordinary stuff. I'm going to touch off on the inside diameter first. And we're going to bore it out to, let's have a look, what does it say there? 1.280 inches. 1.280, so 30 thou over 1/4 of an inch. That gives us that float that we need. That movement, so 1.280. That's the 0. Let's put some on, put 25 on and see if it can cope with that alright. And we'll use the automatic feed. There as well. That's putting all right. That's okay. Right, it's the next day now. I've just come back in the shop. I've been out doing things this morning. I've been over to see my sister as well, so just come in. And I thought I'd continue with this cap for the floating reamer. So let's get on with it. Alright, here we go. Right, let's put the cut on. 25. The bore has to be 1.280, don't forget. We've still got quite a way to go. We're going to use our telescoping gauge to check the bore. If you use these, the easiest way to use them is to close it down, just pinch it up, put it in the bore at an angle so it's cocked up, release it, pinch it back up again, and then just push it down. Put your hand like that, push it down with your thumb, just let it drop into your hand, and you can measure across there. Let's have a look what we're doing. So what we at now then? Very gentle. There we go. There we are. Right, where's me magnifying glass? Right, okay, we're at 1.082. So we've got about 200,000 come off, haven't we? Yeah, we've got about 200,000 come off. Right, let's continue. Take another 25. There you go. Just doing a little spring pass now, and then I'm going to measure it again. It should be about 1.180. It should be about 100,000 down after this. Yeah, that was 1.18. I don't know if you can see it. 1.18. So the 100,000's come off. Right, let's get going. Do 25. And we'll do smaller cuts then. It's on 1.263 now, there's 17 thousandths to go, and I'm just going to do a spring pass. Just do a couple of them, just see where it goes. It's obviously taking something out, I'm not sure how much it will take out though. But I'll do a couple of spring passes and I'll measure it again. Well, we should be on our finishing passes now. We'll do a spring pass after this one as well. Let's just check our bore here. We've just done a spring pass on this. So no idea idea what it's going to be now. There you go. So 1.2. Moved a bit. There you are, it's 1.281. I think that'll do for that. It's a clearance, that is. That's to allow the reamer to float. So 1.281. Right. So that's the boring done. So what we've got to do now, we've got to turn the spigot on the outside here. Now we've done that, we might just put a little chamfer on there as well. But let's turn the spigot first, and we'll do all the chamfers after. And then we'll look at parting it off. Right, let me show you what we're going to do now on this little cover. We've got the, I'm trying to look over the top as well, you see. This is our cover here, and if you look on the outside, there's a spigot here that locates it in the body of the floating reamer holder. Now interesting, that's only a 32nd of an inch deep, which makes it difficult to get the micrometer on there to measure that. So what we're going to do is turn that a little bit longer, and when we get it to size, what we're going to do then is face the end off to the 1/32. We've got plenty of material there, and then we'll part it off. Right, let's get cracking. I've zeroed the outside, let's just check that. That's the zero. That'll do. Let's just zero the end. That's a little easier. Okay. So what we'll do. 30,000, so we're going to turn it probably about a 16th, maybe 332s, and then we'll face that off like we just said. As long as we can get the micrometer on, we're okay. Dimensional check now. Right, let's check the dimension. Let's just see what this is like. Should be very close now. Should be 1.55, 1.559, but we're about 0.4, 0.5 over, aren't we, on that bore? This here. Remember, slightly oversized. So if we take 5 off this and 2.5 off, or 2.5 now cut, that should finish it. So we zeroed that out. It's 0. We'll take 2.5 off and just see what it looks like. Let's go with the 2 already. And we'll back face this as well. Oil on there. Zero that out in case you have to come back to it. We'll go past. That'll do. 1.5, 4. And you can see there, can you see that? You're focusing for you. We'll just test the body, see if the body fits on there now. We made this the other day. There you go. It fits on nice. I don't feel any movement, so that'll be nice. We'll leave it exactly where it is. We'll just skim that face off now to depth, which is a 32nd. So let's just check. It's 5,000 extract put on, won't it? Yeah. So we'll come back 32, thereabouts. That'll do. Just lock it off. Just skim straight across. It's 1/32 thick the spigot is. 1/32 deep. It's not much. Very sharp. Okay. On there. Just take it easy. Just using my thread cutting tool, put a bit of a shampoo on. Looks all nice. Now, can we get that in? Don't think we will. I've got another tool that come in from this way. We'll use that. Okay, what I'm going to do now then, I'm going to mark the PCD. I'm going to use this thread cutting tool here, and I'm just lining it up with the edge of the piece of steel, which is 2-inch diameter, and I'm going to feed in 1/8 of an inch with that. PCD is 1 3/4, yeah, it is 1 3/4, so we're going to feed in 1/8 of an inch. I'm just going to scratch the PCD on there. And we can then mark out, we could use the dividing facility on the lathe here, just mark the 4 holes. Because what we can do is put the cap in the body, and then we can just transfer the holes through. Because this body is only ever going to fit, sorry, this cap's only ever going to fit on that body. So yes, we can do that. Yeah. Right. So what are we doing now? That's just touching. I can feel the pressure on it, isn't that? Let's see what happens when we rotate this. I think it'll do enough to mark it, and it has. It's marked it, yeah. That's all we want. We don't want anything else. Right, okay. Now we know that's on center line, that tool. So all we've got to do is engage this on the 0. So I'll just need to move you out the way. Alright, I've set this at 0 on the mark there. Yeah, so this can be our first mark. Have a look. Just have a look. There you go. There's a little mark now. Pull this out. Right now, 15. That's 60 teeth on this. There you go. It's in. There you go. 15, 30. Touch more. There you are. 30. There we are. And we want 45, don't we? Just put it the other way at it. 45. So yeah, we got 4 there. You've just seen my head. You don't want to see that, do you? We've got 4 marks on that now. So we've marked all the holes for our PCD. Now it's a pretty straightforward exercise. You can see how simple it is. We could set the milling machine up, no problem at all, and we could use the PCD function and things like that, but it's easy enough just to do this, isn't it, for what it is. If there was any necessary precision, if I was making these components for someone, or it was a specific job or whatever that needed precision, we'd put it on the milling machine, but it's just not required for this. I'm happy if we've got it accurate enough, just doing what we've done. Right, okay, we need to think about parting this off now. I need to get the parting tool set up, take this out, set the parting tool up, and we'll get that done. I'm just setting up our parting tool. You've seen me do this before. We're on 0. I've zeroed it out. Alright, it's 86.6 thou thick, isn't it? So 86.6. Oh, too much there. There you go. 86.6. 0. Now, what is it on the drawing? 1/4 of an inch. So 250. Right. I'm going to lock it off. We'll zero that now. And we'll just lock the carriage off. Do what we normally do. We'll go in so far, extract the tool, put a chamfer tool in, chamfer the edge, and then we'll come back in with a parting tool and finish the job off. Okay, you ready? Cutting oil on that fella. Right, let's go, eh? Chamfer tool in. If we get it in. If we get a chamfer tool in. We'll see. Right. There. We'll have to see. And we'll get it in. Just, I think. Only just. Just about touching. There we go. Only just got that there. Very lucky. Right. Let's finish off. some speed going. What we'll do as well is we'll get we'll use that centre. I'll try and get it in. I was going to use that to hold that part when it's ready to drop off, but we can't do that. So what I might do is use this. Okay. There you go. There you are. So people say it's impossible to part off on small machines. That's not quite true. Rear tool post. That's the key to success with parting off on a small machine. Alright, excellent. So I'll switch it off. Yep. There's our piece. What I've got to do now is take that burr off. And then we've got to drill the holes, count the sink. That fits nicely in the body now. It's a nice fit in there actually. It's a very nice fit. There's no movement at all in that. See that? See the big burr there, we've got to shift that first obviously. That's nice. Excellent. Right, I shall clean that off. Now we'll look at drilling them holes.